Hey everybody, this is Kevin, and this is my second soldering project on my channel, and it's another Eggtimer product. This is the Eggtimer Ion. It's a Wi-Fi enabled altimeter, and what's really cool about this one, and what I'm really anxious to test out, is that it will communicate with my receiver case that has the voice modulator in it. So the voice module should read out the altitude in real time as this is tracking upward. Assuming this is somehow going to tie into my onboard GPS transmitter. I'll have to work all that out once I get it done and built and connected and everything. But this should give me the ability to, again, follow the altitude in real time, which I'm really excited about. So let's get on into it. Let's rip it open and do a quick inventory check. When I built my last build on the channel, my mini transmitter, I had already built one, so I kind of knew ahead of time what I was doing. This is my first time seeing this product, so I'm gonna go a little bit slower, more methodical, but of course I'll edit out all the boring parts. But let's do a quick inventory. It says we should have a circuit board with a pre-mounted sensor, so let's go ahead and rip this open. Okay, so we should have our circuit board with the pressure sensor. That's going to be, here, I'll show you the pressure sensor. That little metallic box with the itty bitty hole in it, that's your barometric pressure sensor. So, got that. We've got the pre-programmed Wi-Fi module. That's going to be this guy here. Maybe this is the transmitter. I'm not quite sure how it's going to communicate with the receiver just yet. But wow, lots of stuff going on there. Okay. And then we got the smaller parts. We need a an 8-pin serial jumper EEPROM. So there we go. There's our 8. No, that's not it. Is that going to be it? Yeah, that's going to be it. It's got 8 pins on it. Okay, so that's going to be our serial EEPROM. Then we've got our rectifier diode. That should be the diode right there. Resistor marked 102. There's a bunch of little resistors here. Let me find the 102 one. That looks like it. Yeah, 102, and we only need one of them, but they give us 2. Nice. And then we've got the 4.7K resistors marked 472. Looks like this one here. 472. We need 2 of those, so they give you 3. Nice. Then we got the resistors, the 10K resistors marked either 103 or 1002. That's quite a spectrum. Looks like we got the 103 version. Okay, gives us 2 of those. We only need 1. 22K resistor marked 223. Hope it's not a bullet. No, it's resistor. 223 resistor. Need 1 of those. We got 2. Okay, we need 3 ceramic capacitors. They give us 4. So we only need 3 of those. 22 UF ceramic multi-layer capacitors, brown, not marked. How is that different than... Bear with me here. Oh, okay, I was totally wrong. These are not the... Okay, scratch that whole last part. These are not the ceramic capacitors we're looking for. Going back to the one we thought it was, it's going to be the brown capacitors in the paper. Okay, it's this one here. Remember, with Eggtimer says paper, they're referring to white. I made mention of that in the last video. So we're going to need 3 of these. They give us 4. Okay, sorry about that blunder there. Okay, getting back to the next one. We've got a single 22 UF ceramic capacitor. Now that says clear plastic, but this one is obviously in red. But it's the only thing that matches. So that's interesting. Okay. We have 4 through the hole resistors. Value not important. Okay, that's going to be these guys here. Okay, yeah, these, we're going to need them just for the lead wires. Okay, those are the through hole resistors. Then we've got the 10mm magnetic buzzer, this guy right here. Then we've got a 6-pin header. Got it. The 2-pin JST connector. Got it. Now it's for the battery. We'll see if that lines up with my, I've got another type of JST connector, the red ones. If it lines up, great. If not, I'll have to use my own connector. And a shorting jumper. It even says comes with 2, but 1 is a spare. So we do have 2 jumpers. So, okay, and it does say it comes with another bag of solder. However, I still have my existing solder from my last project, quite a bit left. So we're gonna use this primarily. If I run out, then we'll jump to the new one, but I think we'll be good. All right, let me clear the board and we'll get going on this project. Okay, the first step is mounting the 8-legged EEPROM onto the main circuit board. So let's go ahead and get our knife out and carefully open this package up. And this is a polarized unit in that it is one direction only, so we have to be careful how we mount it, and I'll show you what they say as far as mounting it goes. Okay, got it out. Okay, now you'll notice on the board, up in the top left corner, there's a little square within the square. Okay, that needs to correspond with our EEPROM. Let me rotate it so you see there's a little dot in the top left corner. So that dot corresponds with the square on the pad. So it's going to sit like that. And we're going to do the top right corner first just to get it anchored down, and then we'll go ahead and do the remaining remaining 7 legs. I'll clean off the tip a little bit with my brass wool. Okay, I'm going to take our solder and we're going to do, again, just tin the top right pad. Okay, and we're going to set the EEPROM into it. I'll get as best alignment as I can before I start. Okay. Okay. Let it cool. Looks good. All 8 legs are over their pads. Beautiful. Okay, we're going to rotate it and do the opposite corner just to help anchor it and hold it in position while we do the remaining legs. Okay, I know I'm covering it, but I'm using my finger to help push the whole thing down so all the pads are flush to the surface. Okay, that looks really good. Okay, that was a little nerve-wracking. Those are my tightest pads right there that I've ever done as far as proximity to one another. They're really, really close. Okay, and they recommend 15 seconds between each joint to let the part cool down. So I'm going to do this corner now. come back to this side and do the bottom right corner. And again, it's off camera, but I am constantly running my iron into the wet sponge to help clean the tip off between each solder joint. Okay. And we need to be careful not to use too much solder because we have run the risk of bridging the connectors together, and we don't want anything touching. Okay, so I'm going to do the next ones in fast time. Let me do some time lapse here and speed things up for you real quick. Okay, you may have seen in the last clip there at the very tail end of it, I accidentally did what they warned you not to do, was to get too much solder on and bridge two legs together, and these two legs here ended up becoming one solid hunk of solder. Now you probably see this shiny stuff here on the tape. I'll explain that in a second. I went to the manual and it said if this does happen, simply get some solder wick, heat up the solder, lay the wick down, and then just peel the wick away and it'll pull the solder off with it. Well, guess what? I don't have any soldering wick. So what do? I jump to YouTube and I look up how to make homemade soldering wick, and it was ingenious. A guy showed just take some wiring, strip off the insulation and twist it all together and coat it with flux, which I do have plenty of flux. I use some rosin paste flux. And I just saturated it in the flux, and then I heated the solder, and I laid this on top. I pressed it into the joint, and I just peeled this back, and it pulled the solder right away from the joint. Miraculous. It's beautiful job. So now, in fact, those are very clean solder jobs. That might be a great technique just to complete any soldering, because those are four finely looking pieces. I went over them with the iron again just to make sure they are adhered to the pads, and they are. So anyway, that crisis has been averted. So we're done with this step. Now we'll move on to the next. Okay, the next step is taking two 0.1 UF capacitors and mounting them to the board. So let me remove the backing here. This is the one that comes on the white paper backing. So pull back two, lay them out, and there they are. Okay, now they're going to go on these two pads right here, just above the EEPROM we mounted, and then these two pads here right below the barometric sensor. That's where these two are going to go. So let me, and I'm going to do two at the same time so we don't have to turn the board around so often. Go ahead and heat up the pad here and get it tinned. And we'll go ahead and do this one at the same time. Okay. Take our tweezers, and we'll grab one of them, and we'll lay it in this place here. Okay, and we'll take the second one and lay it on this one. Okay, now we can turn the whole thing around and do a good complete job on the other two sides. Okay. Beautiful. And we'll come back and clean up these two. Perfect. And we'll turn the board around and do the other sides. Okay, and we'll come back and clean up these sides. Nice. Okay, now we got to do the 102 resistors, and that is appropriately marked 102. And if I can find them. There they are. Okay, just need one of these. And it's going to go in this spot right there. That's actually marked. You can guess it. 102. Okay. And getting these out, you got to look. You definitely don't want to lose them when they fall. Okay. Take our iron, a little solder, and we're going to put 102 right here and tin the side. Okay. I tried to get fancy with it and push it down. That didn't work. Let's straighten it out. Okay. And we'll do this side. And clean this side up. Okay, and the next one goes right next door to that. That's the 223. Well, it's the 22 UF capacitor. It's marked 223. So let me find that one. And that should be the brown one without any markings on it. Let me confirm that. No, it says it's marked 223. Let me go through my bag of goodies here. Ah, there they are. Okay. 223, and we just need one of these, and it's going to go on that pad right next to 102. Okay. Same procedure. This might be getting monotonous to you, but it's a good way to document everything. Okay. And obviously, it's obviously marked 223 because on the board it says 223, so you got to put 223 with 223. Okay. Yeah, that took nicely. Okay, next up is the 22 UF capacitor, and this is the one that they say it's brown, but it comes in the clear plastic. Well, the problem is we only have one one plastic brown one, but it's got a red stripe on it. I don't know what to make of that, but it's really literally the only thing we have left. So by process of elimination, I'm going to put this on the board. And it is not opening too easily either. There we go. Okay. Now it's going to go on the spot right here where it says 22, which coincidentally enough goes with the 22 UF capacitor. So we'll take our solder, clean off the tip, heat up the right side. Okay, looks good. I guess it's good that this is getting monotonous because it means I'm kind of getting used to it and I'm not afraid of it anymore. Okay. But I don't want to get complacent either. So I gotta be careful I don't rush it. Okay. So there's our 22 UF capacitor. Now it's time to mount the diode. Now the diode is, it solders on very similar to the capacitors, but it's shaped differently and configured differently. So we'll take it out of its carrier. This actually might be the hardest part of the project, is removing the capacitors from these carriers. Okay. Now it's going to go, now this is going to surprise you, the diode goes in the spot that says diode. And that's something. And one thing to keep in mind is, just like on our last project, notice there is a white line on the left, near the left pad. And we got to find the stripe that's on the diode. And it is on this side, the left side. So it's going to be oriented that direction. So let me set it down in the right direction. We'll go ahead and tin the pad. So much easier to pick up too with the tweezers. Okay. Little tight quarters here because we do have some capacitors in the area. Nice. Okay, off camera, I've turned the board over and retaped it. It's time to now put down our 0.1 UF capacitor. And it goes on those two pads right there at the top. Very straightforward process, same as before. Tin the first pad. Hit this side. And come back and clean up this side. Okay, the next step will be mounting the Wi-Fi module. So let me go ahead and get the board ready for that, and we'll get right back to it. Okay, this next step is really interesting. I'm excited to do it, but a little nervous at the same time. What they ask you to do is tape your Wi-Fi module down to the board, inverted. So there's about a 1/16 inch gap between the board and the surface because there's a metal plate underneath. And then you're to take these wire resistors that we got and stick the first one in the top left corner hole, like that. Now you can see it's sticking up quite a bit, but it's only down about 1/16 of an inch. We need to solder that to the base. So let me go ahead and do that. Let's see if I can get it to stand vertical here. Okay. Okay, there's vertical. Then they say to clip with some wire cutters halfway up to the capacitor portion of it. Like so. Okay. Then it says we do the other corner. Not necessarily. So we can just put it in right next door, that first one, and just go down the line. Now I can tell you I need to work on my cutting skills because I'm about 1/8 of an inch difference. So I'm gonna cut that one right up to the capacitor. But we'll trim all those up and equalize them later. Now we flip this over and do this side. And I'm going to cut it between the other two because I know that's going to be about right for the next 8 or 16 cuts or whatever it's going to be. There, that should be good. And we'll set that one in the hole. And then after this one, I'm going to speed up the video for you because you talk about monotony. Whew! It's going to get very monotonous here. Okay, I thought I'd never get to say this, but I got them all on. That was that was really something. Let me go ahead and untape it. Well, let me go back. They say I need to cut them all to length, and they are not all equal. So let me kind of go down the line here and choose the tallest. There we go, that worked. And there. Okay, that's actually pretty decent. Okay, so they're all the same length, and we'll go ahead and let me take it off the board here. Okay, take a look at the job up close. Is it perfect? No, but nothing I ever do is. But it'll suffice. So we'll move on to the next step. Okay, off camera, I went ahead and took the board here and I trimmed off as best I could all the bottom edges. It's really tight, and my wire cutters are not exactly small, so I did the best I could trimming them, but they're at least not sticking out above the metal board there. The next trick, and I may have to speed this up for sake of sparing you the pain and agony, I need to slip all 16 of these pins into the holes on the main board. So let me see if I can do this without losing my mind. I'm gonna have to finagle each one. Well, that's one side. Okay, let's see if I can do the other side. And there we go. All right, we got them all in. That was a lot less painful than I thought it was going to be. Whew, okay. Now they say that, work them in until it's about a 32nd of an inch above the board. That looks to be about a 16th. I'll be honest, I don't think I can get it any more than that. That looks pretty good. The solder on the pins is hitting the board, but I think that's pretty good. So I'm gonna set this down now. Well, maybe not so close to the pins. And the side. Okay, that should hold things steady enough. And what I'll do is I'll do the first corners. I'll do 2 opposite corners, and I'll take it off and make sure everything looks good. So we'll go ahead and solder these pins in. Sorry, I bumped the camera there. This is pretty tight quarters I'm working in. That one, and we'll do this opposite corner here. Okay, let's take it off and see how everything looks positioning wise. You know, I think it looks pretty darn good. So with that, I'm gonna go ahead and probably speed up the tape again as I go through these rather quickly. and we'll go from there. Okay, that was one of the most monotonous things I've ever had to do in my life, but I got all 16 pins soldered down and cut as low as I possibly could given the type of wire cutters I got, but I think we're okay. They're not sticking out too far, but everything's nice and even, everything looks straight. Yeah, I'm pretty pleased with it. So let's move on to the next step. Okay, this next step is rather interesting. They give you the 6-pin header, but you need to convert it into a 3-pin header. So they say to cut 3 pins off, and there is a little bit of a groove between them. So I'm going to see if I can do it with the knife, as opposed to clipping them with the wire cutters. So let's see if this knife will go through on that groove. Yeah, it did. Yeah, that's the way to go. That was pretty good. I don't know why they just don't give you a 3-pin header unless there's another use for the other 2 or 3 later. But the next step is to take the 3 short ends and run them through the 3 holes on top of the board here so the pins stick out the bottom. Okay, so what I'm going to do is take some tape and lay it over the pins, keeping them in. And what the tape did was it just pulled it right out on me. Let's see. Try that again. Okay, let's do it this way. There we go. That's what do we do. And we'll tape the board down. Okay, and we'll solder those 3 pins. There, just like that. Like perfectly straight. Okay. Okay, the next step, and now I know why they had us cut 3 off, because I had to cut a single off the header from the remaining 3, and it goes into this little hole here that's for the 3-volt option. And this is if you're going to run power to like a telemetry module. Not quite sure what all that entails, but I'd rather, and it's an optional piece, so I'd rather put it on now and not need it than wish I'd put it on later. So let's go ahead and tape it down just like we did the other header pins. Okay. All right, we'll solder that one. This is just a simple 1 pin piece here. But there we go, nice and straight and ready in case we need it. Okay, the next step is mounting our buzzer to the board, and this one you got to be careful. It is direction important. The longer pin on the buzzer is the positive pin. See a little, it's not focusing. There, a little plus sign, and then on the board, the left hole here has the plus sign, so we need to ensure that it goes in that direction. So plus goes to plus, fit them both in, and I'm gonna tape this down. I didn't realize how good or how important masking tape was to soldering jobs, but it's become quite valuable. Okay, I'm gonna actually peel some of this back because I'm afraid the soldering iron will hit it, and then we're gonna have burnt paper smell for the next half hour or so. I don't want that. Okay, so we'll tape this down. Okay, simple 2-pin solder job here. Okay. And it says to clip the long end off, so we'll go ahead and clip that off. Clean things up a little bit. The more things you have sticking up like that, the more things will get snagged, and you definitely don't want that. You might be able to trim a little bit off that bottom piece there. Yeah, okay. Okay, that was the negative side, took a little bit off. Okay, now we're moving on to the battery connector options. Okay, just a couple more things left to do. The first is to install the battery connector to the board. And you want to make sure that the notches for the JST connector are facing inward toward the buzzer, and it's smooth side on the back. Okay, we're gonna do that one first, and then we're gonna have to take this remaining 2-pin header and put it in the 2 slots next to it. And this is for your switch. So if you're gonna run a switch on it, you'll have to use the jumper. If you're not gonna run a switch, if you're not gonna run a switch, use the jumper. If you are gonna use a switch, then just leave it open. Either way, the circuit is not complete for the battery unless those 2 slots are connected. But anyway, that's a whole lot of jargon for way over explaining things. But let's go ahead and get that taped down. I don't like the way that tape is, or like that. Tell you what, I need some new tape. I've been using the same piece of tape over and over and over again, and it's wearing out. So let's get it aligned the right direction. I'm having trouble with the absolute easiest parts of this build. Okay, there we go. Nice and, well, it was tight until it popped off. There we go. Where's it at? Oh yeah, it's these 2 right here. Okay. I'm just looking at a board going, what's what? Okay. Ah, my stand fell. Okay, go ahead and get these 2 pins in. That's a little crooked. I don't like that. That's too crooked for my taste. So I'm going to heat those up and maybe put a little bit of a twist on it. Yep, that did it. One of those is doesn't look like it's as secure as it used to be, so let me fill it in a little bit better. It went crooked on me again. Ah, okay. Well, we'll just have to keep playing with it. And I have successfully bridged the two wires together. That's splendid. So now I get to use my little de-wicking tool. It's not a bad idea to actually show you how this works. So, take some flux, spread it on the wire, and that will help pull the solder off the board and into the wire. Okay, so okay, didn't work as well as it did the first time. Maybe need some more flux down on the bottom edge. Let me strap that down a little bit better. Okay, we're gonna get this. We're gonna get it and show how it's done. And that did it. Even though it's sliding around a little bit. Well, you know what? I'm not sure. I don't think it did. Let me turn the camera off and let me do some investigation on this. Okay, literally like 10 seconds after I hit the stop button, I just touched it with the iron, and the flux wicked it away from each other. So there's no more bridge between those two posts right there. These two guys right there. What you see is a little bit of buildup of some flux, but I'll get all that cleaned out with some alcohol and a toothbrush later on. So, okay, so moving on to the last item. And coincidentally, it ended up perfectly straight. So I'm pleased with that. But the last thing we got to do is install this 2-pin header next to the battery connector. I don't know why it's not fitting. Maybe it's got, I think it's a little bit of flux might have dried up in there. I don't know. But anyway, you know, it's holding itself, so I don't need any tape. We're just gonna solder them in. Voila, that's absolutely perfect. Okay, that is the completion of the Eggtimer Ion altimeter, and gotta figure out how we're gonna test it, but yeah, we're gonna get some power to it and get into a rocket and see what it tells us. Well, that wraps up this build video. I have completed the Eggtimer Ion altimeter, and I did some preliminary testing. I was able to hardwire. By that I mean I soldered a one-cell LiPo battery to the backside of the power connector and then put the jumper over the switch, and I was able to power it on, and it worked. I plugged it into the computer through the serial port and was able to communicate with it and pull the passcode off the altimeter for future use. And then I was able to access through my cell phone the Wi-Fi signal from here. I did a preliminary suction test where I cupped it and tried to suck the air out of it, and it downloaded the data onto my phone, and it registered, I want to say 1728 if I remember correctly, and there was a whole lot of other data on there. And now I need to go read the user manual. So far I've only gone through the assembly manual, which had some very basic stuff on it, but I need to get deep into the user manual. It appears that this has a heck of a lot more functionality than I knew before I bought it, so I'm really excited to see what it can do. And I guess the only way to do it's really to get it out to the field and put it through its paces. And I'll report back to you from the flights on lunch days how it goes. So with that, I hope you enjoyed watching the build. It was a lot of fun for me to do it, and I hope you enjoyed watching alongside. And until next time, God bless, and we'll see you on the next video. Bye-bye.